All right, welcome to day 1.3, Segment Addition Postulate and Angle Addition Postulate. These are our video notes for geometry. We're going to talk about what these mean. The key words I want you to focus on right now are segment addition and angle addition. You guys know the meanings of those words, even though we haven't really talked about what a postulate is yet. So today we're going to be able to talk about these two ideas and what segment addition and angle addition mean. And it's really a pretty basic concept if you know what segments are and you know what angles are from the last lesson. But I do want you to understand what the word postulate means at the beginning. It's kind of just a fancy word. Another name for postulate is axiom. Axiom, with an M. And that is just a statement that is true without being proven. It is so basic and fundamental that it is accepted as true without having to prove that it's true in math using logic. So that's all you need to know about a postulate right now. And so these are some of our most basic mathematical or geometric facts right now. All right? And so we're going to talk about segment addition first, and that is this. If A, B, and C are collinear, you'll remember that from the first lesson. Collinear means all on the same line. So if A, B, and C are all on the same line, they create this segment or series of segments. You recognize that we could have segment AC, but I could just focus on part of it and have segment AB, or I could just focus on the other part and have segment BC. So there's actually three separate segments I could look at. Well, if they are collinear and B is between A and C, that word between does not mean in the middle. It just means anywhere between. So you can see B is not in the middle of AC, it's somewhere between A and C. If that is true, okay, then the next keyword is addition. We can add these two segments to get the entire segment. Okay, so AB plus BC, those two lengths have to equal the total length of AC. Okay, I can write it again over here. AB plus BC equals AC. The main idea that I want you to take away from this entire lesson is this concept. Part plus part equals whole. All right? This part plus this other part equals the whole thing when we talk about the length of segments. Okay? And so we can use that to set up some equations and solve some problems. So in this first example here, we're told that EG, that's from here to here, is 71. So I'm actually going to mark that length as 71 like that. Well, these other two parts are expressed in variable expressions. So we're going to use a little bit of algebra here. We're going to set up an equation and solve it. The idea is that part plus part equals whole. Even though I'm using different letters than A, B, and C, I can set up my part plus part equals whole like this. 8x minus 17 is one part, plus 5x minus 3, that's my other part, has to equal the whole thing, 71. Well, that's an equation with a single variable. We should be able to solve that using our algebra skills. We're going to combine like terms first. 8x and 5x becomes 13x, and negative 17 minus 3 is minus 20, and that has to equal 71 still. And then I just solve the equation. The first thing we would do is cancel out the minus 20 by adding 20 to both sides. Kind of running out of room, but you should be able to follow. Okay, so I'm going to come over here. On the left side, the minus 20 and the plus 20 cancel, so we're left with 13x. And then 71 plus 20 is 91. And we just divide by 13 on both sides. And then we get that x equals 7. 91 divided by 13 is 7. So when we were told to find the value of x, that's what we did. When I plug x in, I would find that it does work out to be equal. Okay? We're going to skip over number 2. We're going to come down to number 3. All right? We're again using the idea that part plus part equals whole. Okay? So if JL is equal to 5x plus 2, so the entire thing this time, the whole, is 5x plus 2. They want you to find that actual length. When it says find JL, I actually want a number length. I want to know what is the length in number form of JL, not just the 5x plus 2. So when it says find JL, that's the length of JL. That's what that means. And so we can actually set up an equation and solve the equation, but then we'll plug our answer back in to this to find out what the actual number is. So the first thing we're going to do is set up our part plus part equals whole equation. These are the two parts. This is the whole. So we say 27 plus 3x minus 1 equals our whole thing of 5x plus 2. Now, this is a little bit different. The whole thing was given to you as a single number last time, but now one of the parts is given to you as a single number. So just don't always assume that it's this expression plus this expression equals the number. It's not always like that. You have to identify from the picture what the parts are and what the whole thing is. Okay, so now we can start to solve the equation. Now on this side, we can combine like terms here. 27 minus 1 is 28. So this side is really 3x plus 26. 27 minus 1 is 26. And this side is still 5x plus 2. Okay? Now, when we have an equation with variables on both sides, remember that you want to get the variable to one side and the numbers to the other. So since 3x is smaller, I'm actually going to subtract 3x from both sides so I don't get a negative coefficient of x. And then I can subtract 2 from both sides to cancel that out. So on this side we cancel the x's, on this side we cancel the constants. And so we get an equation that is 24 equals 2x. And then we just divide by 2, and x equals 12. Now, I won't always take so much time in the video to solve the equations. I'll let you do some of that on your own, but it's a good refresher at the beginning of the year. Now, this is not our final answer. We were supposed to find the length of JL. So what I have to do, I'm going to come over here where I've got some room. Remember, JL equals 5x plus 2. So I'm going to plug in 12 for that x, because x equals 12. So I'm going to plug it in now and actually find a number answer. Now, 5 times 12 is 60, if you remember your multiplication facts. Then I have to add 2. So the full length of JL is 62 units of measure, whatever those units of measure are, which we aren't told, so that's okay. All right? And so that is how we can use some algebraic skills with this part plus part equals whole idea to find lengths in a given situation. But they have to be, with lengths of segments, we have to have 3 points that are collinear. Sometimes we'll have more than that. But for now, this is what I want us to do. Okay? We're going to look at number 5 here. I'm going to let you take some time to try and set up your equation. Pause the video so you can do this, but try that part on your own. Okay, we have a part, and then the whole thing. So part plus part equals whole. So pay attention to what these labels tell you in the sentence. Once you have that equation, go ahead and click play to see the next step. All right, pause the video if you need more time, but otherwise this is what you should have. This first part, sk, is 13x minus 5. The other part, ky, is 2x plus 9. So I'm going to add those two parts and set it equal to the whole thing, sy, which is 36 minus x. And you'll notice none of the parts or the whole were given to us as single numbers, like in the previous two examples. That's okay. We are still just working with single variable equations. Okay, the next step here is to combine our like terms and simplify this to make it a lot easier. 13x and 2x becomes 15x. Negative 5 and positive 9 becomes positive 4. Sorry, 36 minus x is what we have there. Now that I've got the variables simplified on each side, I need to get the variable over to one side. Since this minus x is a smaller coefficient than the 15, I'm going to add x to both sides. Or add 1x, if you want to think of it that way. And that means I'll need to subtract the 4 from the other side. Okay? And so, 15x plus x is 16x. 36 minus 4 is 32. So we have it set up to where we can now divide by that 16 to figure out what x is, and x is 2. So that's a blank here, but then they give you these blanks because they want the other parts of this. They want the two parts and they want the whole thing. So all we have to do is plug it in to these 3 expressions when x is 2. Okay, so I'm going to do 13 times 2 minus 5. I'm going to do 2 times 2 plus 9. And I'm going to do 36 minus 2. Well, that is the easiest one to do. 36 minus 2 is sy. So 36 minus 2 is 34. Then I'll do 2 times 2, which is 4 plus 9. That's 13. So ky is 13. And then 13 times 2 is 26. Let me write this one out. 26. And then I have to do minus 5, so that's 21. Now what you should notice is these two should add up to equal this one. And they do. 21 plus 13 is 34. Okay, because I did not catch this in time, numbers 6 and 7 are actually missing some parts. They didn't print correctly, so we're going to take a look at those in class. So we're going to skip over those. So go ahead and turn to the back. And we're going to talk about the same idea, but it's called angle addition. Now we can do the same concept with angles. All right? With an angle addition postulate, we have a drawing somewhat like this, where I have two angles combining to equal another angle. Well, the way we refer to this is the fact that point D is in the interior of this angle. Okay, it's between the angle ABC in some ways on the inside, not outside. So it creates these other two smaller angles that make up the whole thing. And again, it's the idea that part plus part equals whole. All right? And so what we're going to do is, D is in the interior, and if that's the case, then the measure of angle ABD plus the measure of angle DBC has to equal the whole thing, which in this case is the measure of angle ABC. Okay? Okay, the part here plus this part equals the whole thing in measure there. So we're going to get through probably one example here. We may not get through a lot of these in the video, but that's okay. We'll do some more in class. Here's our first example. And we are told that in this diagram, the measure of angle PQR is 141 degrees. Well, these two parts are given as algebraic expressions. So if we set up our part plus part equals whole, we're just saying this expression plus this expression equals 141. And we don't have to write the parentheses. So this is 13x plus 4 plus 10x minus 1 is what would add up to a total of 141 degrees. And so once again, we combine like terms. 13x plus 10x is 23x. 4 minus 1 is plus 3. Subtract 3 from both sides, and we get 23x equals 138. Divide by 23 on both sides. And we get that x equals 6. But they also want for these other measures, PQS and SQR. So we're going to, again, substitute or plug 6 back in for x here. So I'll do 13 times 6 plus 4, and 10 times 6 minus 1. Well, that's the easier one to do. 10 times 6 is 60, minus 1 is 59. So the measure of angle SQR is 59 degrees. And 13 times 6 is 78, and 78 plus 4 is 82. This is 82, this one is 59. And make sure you put degree symbols after those measures there. Not after the x, but after the two angle measures we just found. Okay? Now, we've got some more examples here. We're not going to get through all of these in the video because that would make the video too long. So what I'm going to have you do is, if you want to try any of these on your own, go ahead and do that before you come to class. Otherwise, we will talk about these and get a little bit of time to work on these in class together.